Hi dear students. So already we have discussed about the angular velocity. So as we are having an angular velocity, there should be an angular acceleration also. In the case of the linear acceleration, you know that there is the rate of change of linear velocity with respect to the time. That was the linear acceleration. So in the same case, same as like that, the angular acceleration will be the rate of change of the angular velocity with respect to the time. So here the angular velocity, it is represented by the omega. We have studied that v is equal to r cross omega, where v is the linear velocity, r is the radius, and omega is the angular velocity. And here the angular acceleration, it is represented by the term alpha, and alpha is equal to d omega by dt. If there is no acceleration, then the omega value will be a constant. That is, when alpha is equal to 0, that is d omega by dt is equal to 0, that is omega will be a constant value. That is, the angular acceleration will be constant if there is no, angular velocity will be a constant if there is no angular acceleration. Okay. So we can say the angular acceleration alpha is the time rate of change of the angular velocity. If the axis of rotation it is fixed, and as well the direction of omega, if it is the axis of rotation means the direction of the omega, if it is fixed, then the alpha value will also be a fixed one. Alpha value will be also a fixed value. Now let us come to the angular analog of the force, that is known as the moment of force. Moment of force is actually, it is also known as the torque also. Here you can see a particle P. Upon the particle, a force is acting, that is F. And you have to find out, and it is pivoted at a point, that particle it is pivoted at a point O. And you have to find the angular force which is acting upon the particle P. The angular force which is acting upon the particle P, that you have to find. So as the force acts in this direction, the movement will be, as it is pivoted here, the movement almost will be like in this direction. Okay. So that angular force, the angular force due to this linear force, the effect of the force in angular motion due to the linear force is known as the moment of the force. And the moment of force, it is represented by the term tau. The term tau, it is given here, the tau. So the moment of force, it is represented by tau, and which is actually the vector product of the radius and the linear force F. Tau is the vector product of, that is r cross F, vector product of radius r and linear force F. So here the moment of the force is acting on the particle with respect to origin. The origin is, the particle it is pivoted at the point origin. So the distance between this pivoted point and the particle it is r. That is the position vector of the particle P. Then the torque value, if a linear force F is acting upon that particle, then the torque value will be is equal to, the moment of force value will be is equal to tau is equal to r cross F. And if you want to find out the magnitude, it is the magnitude of torque. That is the magnitude of torque. So you can see here this one, it is a bolded one. Bold means it is representing the vector. So now as you want to find out the magnitude will be represented by unbolded letter. So here tau, that is the magnitude of torque, is equal to Rf sin theta. That is r cross F, it is Rf sin theta. The magnitude it is Rf sin theta, where this r and f are the magnitudes of vector r and vector f respectively. And theta is the angle between this r and f. Theta is the angle between, this is the position vector, and this is the F, force. And the angle between the force and position vector r is the theta. Okay. Now, the moment of force is having the dimension ml square t raised to minus 2. As you know, the work and as well the energy both are having the same dimension. But in this case, the moment of force is having a moment of force is it is actually a vector quantity, but the work and energy both are not a vector quantity. And the SI unit of the moment of force is actually Newton meter. The R into F. F is having the unit Newton and the distance. It is having the unit meter. So, and as well, so we have seen that R F sin theta, that is the magnitude of the torque. So this RF can be written as R sin theta F can be written as R perpendicular into F, or R F sin theta, that is torque can be written as R of F sin theta, R into F sin theta, that is R F perpendicular. Actually here R perpendicular, that is R sin theta, is representing the perpendicular distance. In the figure you can see. Here the vector F you are extending little bit backward, and you are finding out the perpendicular distance between this F or between F and the origin, the perpendicular distance. Here as per the angle, this one it is theta, the opposite angle also will be theta, and this distance will be R sin theta. So R sin theta can be represented as R perpendicular, that is the perpendicular distance from origin to the vector F. You are extending the vector F, there is no problem. That is you can in the case of that vector addition, you have just changed the positions. You have changed the position of the vector, but you are not supposed to change the length, and as well you are not supposed to change the orientation. The direction you cannot change, but you can change the position. The same way here you are changing the position of vector F from here to here, and you are finding out the perpendicular distance between this force F, the vector F and the origin, that is R sin theta. In the same way, so R perpendicular, that is the R sin theta, that is the perpendicular distance. Likewise, you can write the tau as R F sin theta, where F sin theta will be F perpendicular. And this F perpendicular is the component of force in the direction perpendicular to R. So, the component of the force which is perpendicular to the position vector, that is the F sin theta. So, you can see this torque can be 0. Either R should be 0 or F should be 0. If the displacement, if it is 0, or the linear force if it is 0, or else this theta, the angle between F and R, both are 0. In such cases, you can see the torque value will become 0. If the displacement is 0 or force, linear force is 0, in both the cases the torque will be 0. And as well the theta between, that is if you are applying a force and the angle between the position vector and as well the force applied, if it is 0, that means that the force it is acting linear, as a linear force, a purely linear force it is there. There is no chances of rotation. Okay. So in such cases the torque value, the moment of force value will become 0. So here you can see that is tau is equal to R cross F, that is the vector product of two vectors R and F. So in this case, if you are reversing the direction of force, then the torque value will reverse. And as well, if you are reversing the direction of the position vector, if you are reversing the direction, then also means you are reversing the position of the particle, then also the torque value will reverse. If you are reversing both the position vector and as well the force vector, then there will be no change. The direction of the torque will be the same as it was earlier. Okay. Now let us come to the angular momentum of a particle. So we have seen the angular acceleration, angular velocity, and as well the angular force, that is the moment of force, that is torque. Now let us come to the momentum of the angular momentum of the particle. This angular momentum of the particle, you can relate this one with the torque, that is tau is equal to r cross f, where f was the linear force and r, the radius, and the torque, the angular force. So here the angular momentum, it is represented by the term L. So L will be is equal to r cross the linear momentum, where in the case of the torque it was r cross the linear force. Here it is r cross the linear momentum, r cross p. R cross p is actually the angular momentum L. So here r cross p, you can in the same way that we have considered in the case of the torque, that r cross p will be rp sin theta. So the magnitude of L will be rp sin theta. This rp sin theta can be written as rp sin theta or r sin theta p. Rp sin theta will be rp perpendicular or r perpendicular. R sin theta p, it is r perpendicular p, where r perpendicular, it is the perpendicular distance of, or distance between the vector p and the origin, and as well p perpendicular is the perpendicular component of p, or the component of p in the direction perpendicular to r, the component of p in the direction perpendicular to r. There is a magnitude will be same, but the direction should be perpendicular to the direction of r. So here also the L can be 0 either if p is 0 or r is 0, or the theta value. Either theta can be 0 or 180. In both the cases the value of L will be 0. Okay. So L can be 0. The angular momentum value will be 0 either if L is 0, R is 0, P is 0, or else the theta value can be 0 or 180. It can be in the same direction or in the opposite direction. Which one? The theta is the angle between the position vector and the linear momentum. If the linear momentum and the position vector both are in the same direction, then the angular momentum value will be 0. If both are in the opposite direction, then again the angular momentum value will be 0. Now the relation between angular momentum and the moment of force, the same in the case of the linear momentum, that is the rate of change of linear momentum with respect to time, it is actually the force. So here the rate of change of angular momentum with respect to time will be the angular force, so that is the torque. So you have to take the dl by dt, the rate of change of the angular momentum. dl by dt is actually d by dt of r cross p, where L is r cross p. So d by dt of r cross p, it is actually in the term of d by dt of a into b. So first you have to find out the d by dt of a, then into p, d by dt of r into p, plus then first term r into d by dt of p. So d by dt of r cross p is actually dr by dt cross p plus r cross dp by dt. Okay. So you can compare this one with the d by dt of a into b. If such a term it is given, that is a and b both should be the functions of time, then the equation will be d by dt of a into b plus a into d by dt of b. Okay. So here dr by dt is actually m into v. V is equal to dr by dt and p is equal to m into v. So first you have to consider this one. So dr by dt is v, that is a rate of change of displacement, that is velocity, and the linear momentum p is actually m into v, that become v cross m into v will be there, where m is a constant, so we have to consider only v cross v. You know that if you are taking the cross product of a same vector, the value will be 0. So that time, the first term will become 0. That is dr by dt cross p will become 0. The remaining will be r cross dp by dt. R cross dp by dt is actually, where dp by dt you have already studied, that is dp by dt is equal to f. So r cross f will be there, dr by r cross dp by dt, r cross f, r cross f, it is actually the torque value tau. So d by dt of r cross p is equal to tau. Okay, that is dl by dt is equal to tau. That is rate of change of the angular momentum with respect to time. It is actually the torque value, and it is related with the Newton's second law of motion, that is F is equal to dp by dt. So we can say the dl by dt is equal to tau. dl by dt is equal to tau, or dl by dt is equal to the torque value. It is actually the analog of Newton's second law of motion in the case of the circular motion. Okay. Now, suppose if we are considering a system of particles, so suppose n number of systems are there. So each one, that is the first particle is having the angular momentum L1, second one L2, and likewise the last one it is having Ln. Then the total angular momentum will be equal to L1 plus L2 plus etc. up to Ln. Then that you can be written as in the form of summation, that is summation of I is equal to 1 to n Li. Summation of I is equal to 1 to n Li. So in the same way, the angular momentum value is actually Li can be written as Ri cross Pi. So L can be written as, here this Li is actually Ri cross Pi. Suppose a random particle I, the Li value will be Ri into Pi. So the total momentum can be written as summation of Li, that is summation of I Ri cross Pi. Now if you are taking the d by dt, is a dl by dt is actually, you know that d by dt is summation of Li, and that is actually summation of I dl by dt, and it is actually the tau I, that is dli by dt, and dl by dt is actually tau, so dli by dt will be tau I. So the torque value will be actually here also in the same as in the case of the linear case, here also you are considering the external torque only. There is no, you don't want to consider the internal torque values. So external torque value you are considering. So if we are considering n number of particles and various amount of torque value, if it is exerted upon the particles, then the total torque value will be equal to the sum of the individual torques values applicable or exerted upon the each individual particle. Okay. So tau can be written as Ri cross Fi, where Fi is the individual. Fi is actually the force exerted upon a random ith particle. The particle number it is I. So 1 to n you are considering, the I can be any one of the particle from 1 to n. So the tau value, actually you have to consider the tau external torque also you have to consider, as well the internal torque also you have to consider. But here the internal torque value is always cancelled each other, so only we are considering the external torque. So tau external is actually summation of I Ri cross Fi external, and tau internal is actually, the reason because of tau internal is 0, that is Fi internal value always, the internal force value is always 0. So Ri cross Fi internal will be 0. That is Fi internal is 0, hence Ri cross Fi internal is 0, and the sum of the I products or n products will be also 0, that is tau internal will be 0. Now let us come to the conservation of angular momentum. The same as there in the case of the conservation of linear momentum, that is, if there is no external force acting upon the system of particles, then the momentum value will be conserved. Same as here, if there is no torque acting upon the particle, a system of particle, then the angular momentum will be conserved. That is dl by dt will become 0, that is L become a constant. So in this case, if there is no external torque acting, then the coordinates of the angular momentum, that is x coordinate, y coordinate and z coordinate, all the coordinates will be constant. When? If there is no external force acting upon the system. Okay. So just go through the textbook, read the textbook thoroughly. So we can wind up here, and the continuation we will do in the next section. Thank you.